So if you recall, last time we had discussed the Java Executor framework, and I talked a little bit about what a thread pool was and said that there were a couple different kinds of thread pools supported in the Executor framework. What we're going to do now is we're going to talk about some of the key interfaces that are provided by the Java Executor framework. So it turns out that there's basically 4 interfaces that are part of the framework. 3 of those interfaces are related to each other through inheritance. One of them is kind of standalone, although you see the implementation is related, as we'll talk about later. So the 3 interfaces that are related are the Executor Interface, the Executor Service Interface, and the Scheduled Executor Service. Those things are connected through inheritance relationships or extends relationships, and then the Java Completion Service Interface is kind of off to its side, and we'll see how it works in a minute. The Executor Interface is the basic one. It basically provides a means to submit new runnable tasks for execution. So you can see it's pretty abstract, right? You say execute, and you give it a runnable. That's called a task. It basically just defines a very, 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 very simple API that decouples the submission of a task from the mechanics of how the task will be run. And it doesn't even necessarily have to be run concurrently, as we'll see later. There's actually a single-threaded executor, although I'm not sure why you would ever use that, but there is one. The more powerful mechanism is called the Executor Service. And this extends the executor, so it extends the Executor Interface, and then it adds a bunch more methods, actually quite a few more methods, in order to manage task and executor life cycles. So you can submit tasks, you can terminate the executor service, and do all kinds of other things using those interfaces. So it's a lot more powerful and interesting. There's yet another variant here called the Scheduled Executor Service. And this extends the executor service in order to support the execution of tasks either in the future in a one-shot-like way or periodically. Once you register them, they will be run over and over and over again. So those are kind of the way that that works. So these are basically time-based tasks. And then the 4th and final core interface is called the Completion Service. And what this does is defines a bunch of methods that decouple asynchronous task invocation from the processing of completed task results. So you're able to submit a task to be run, the task will be run at some point in time, and then you'll get a result back later, or you can come and get the result back later by taking or polling. I like to think of this as kind of a dry cleaning service where you drop off your tasks to do, and then you come back later and get the tasks. Okay, so that's basically the end of the overview of the Java Executor framework. The last piece of the puzzle for our overview is the discussion about how we create the appropriate type of executors. And these are done with something that's called the Executors Interface, the Executors class. And this is going to provide a bunch of factory methods that make things. So this is basically something that's called a utility class. Does anybody know what a utility class is before I define it? See if anybody knows what a utility class is. It's what? It's helper methods, right? But it's very specific. It's a so-called final class. What does it mean to be a final class in Java? You can't extend it, right? You can't inherit from it. So that means it's marked as final, so that's the one and only implementation you're ever going to get. And it has a private constructor. What does it mean to have a private constructor? You can't make an instance of it. And all of the methods are static, which means you can call them as if they were pretty much functions in a language like C, right? You can call them. You don't have to have a this pointer in order to call them. You don't have to have an object to call them on. And so that's what a final class is. Lots and lots and lots of examples of final classes in Java. In fact, in the earlier versions of Java, they would often do this pattern where they would have a bunch of classes that did stuff, and then they would have something with an S at the end, which was a utility class with a bunch of static methods that would make instances of the other classes. And that's exactly what it's doing here. And so these are basically factory methods that create desired executors. So we have a way to make a cached thread pool. We'll talk more about cached thread pools. We have a way to make a fixed size thread pool. We'll talk more about fixed size thread pools. You get to do that in the next assignment. There's work stealing thread pools and so on and so forth. So there's a whole bunch of these different things. There's also something called a thread factory, and that's used to create new threads. And there's something called a default thread factory. So if you don't give a thread factory when you call these various factory methods, it'll use the default thread factory, which by default just makes a thread. So it's just a way of getting a thread made. But you can override thread factory, and you can make your own threads. And the typical reason for making your own threads is if you want to control some of their properties that need to be set when they're made, or need to be set before you use them, like their priority, or are they a daemon, right? Those are some examples of things that you might want to control through the thread factory. All right, so very fast, quick overview of the Java Executors class in the Java Executors framework.